A sigma complex, also called an Arenium ion, is an intermediate formed during electrophilic aromatic substitution when an electrophile temporarily bonds to a carbon on an aromatic ring and breaks the ring's full aromaticity. Think of an aromatic ring like a perfectly balanced playground seesaw that gives the ring special stability. When an electrophile attacks, it grabs onto one of the carbon seats and sits down, which makes that part of the seesaw unbalanced, and the special stability is lost at that spot. The positive charge from this change spreads to nearby carbons through resonance, which helps the structure stay together for a short time. Then a base removes a proton from the carbon where the electrophile sat, and the ring gets its seesaw balance back, restoring aromaticity. Students often expect the ring to stay aromatic during the entire reaction, but the key point is that aromaticity is temporarily lost in the sigma complex, so do not assume it is aromatic at that step. Remember to show the positive charge delocalized to adjacent carbons. Another common mistake is forgetting that the electrophile attaches as a sigma bond to a ring carbon rather than forming a simple pi complex, so draw the new single bond clearly and show the disrupted pi system. Some learners think the sigma complex is long-lived, but it is usually short-lived and exists only as an intermediate before deprotonation restores the aromatic system. Check out www.gumballdegree.com to find more videos and resources on electrophilic aromatic substitution and sigma complexes.